Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi everyone, welcome to my channel. So in this video, I will discuss the pre-lab module, experiment 5, which is about the geometrical optics. The objective to discuss the pre-lab module is, at the end of this lesson, students should be able to explain the experiment to determine the focal length of a convex lens. As usual, in the pre-lab module, there are 3 parts. The first part is the introduction. Take a look at the first question. You need to sketch by convex lens and label the position of F and 2F. So here are the shape of the biconvex lens. You're supposed to write down the principal axis, which is the line joining the two centers of curvature of the lens. The focal point represented by F and 2F is the radius of curvature. For question number 2, write down the thin lens equation and define each symbols. So the thin lens equation is 1 over F is equal to 1 over U plus 1 over V, where the F is the focal length, U is the object distance, and V is the image distance. For question number 3, you need to complete the table for each sign convention. So for the object distance, if the value is positive, meaning that the object is real and located in front of the lens. If negative, the object is virtual and located at the back of the lens. For the image distance V, the positive value shows that the image that form are inverted, real, and located at the back of the lens. And if the image distance is negative, the characteristic of image is the upright, virtual, and located in front of the lens. For the focal length F, positive value shows that the lens is the convex lens, and negative sign shows that the focal length is for the concave lens. Question number 4, you need to draw a ray diagram to show the formation of image of a parallel beam of light incidence on the convex lens and state the position of the image formed. This is referring to the procedure 1. So, for the parallel beam of light that incidence on the convex lens, the image will form at the focal point of the convex lens. For question number 5, an object is placed at a distance between the F and 2F from the convex lens, referring to the procedure 4. So you need to sketch the ray diagram and state the characteristic of image formed. For the ray diagram, the position of object is between the F and 2F. So the red line is referring to the first ray diagram and the second, the green light referring to the second ray diagram. So these two will intercept, and at that point we can sketch the image form. So in this case, the characteristic of image form is real, inverted, and magnified in size. The second part of the pre-lab module discussion is experiment. Take a look at question number 6. For question number 6, state the manipulated variable, responding variable, and constant variable. So referring to this experiment, our manipulated variable is the object distance, our responding variable is image height and also image distance that you need to record, and our constant variable is the focal length of the lens because we use the same lens and the height of the object. For question number 7, what is the relationship between the magnification M and the image distance V? So, magnification M is directly proportional to the image distance V. Question number 8, why the focal length of the convex lens has to be estimated? So the reason why we need to estimate the focal length referring to the procedure 1 is we want to set the range of our manipulated variable, which is the object distance, between the value of that F and 2F as in the procedure 4. Question number 9. How do we set up the convex lens to get the estimation of the focal length? So this is the step that we do. First, you need to choose a far away object outside the laboratory. We consider that this object is at the infinite because we know if the object at the infinite, the image will form on the focal point. So after you choose the object at the infinite, you need to adjust the screen back and forth until a sharp and inverted image is formed on the screen. When you get the sharp image on the screen, you can measure the distance from the screen to the lens. The value of V is equal to the estimate focal length. For question number 10, you need to label the figure 5.1 below. So referring to the figure, we have the light source, power supply, cardboard as our object, lens, and then we have the lens holder and also the screen. You will use the meter rule to measure the distance of U and V. For this experiment, you also can change the light source, cardboard object and the power supply with the object in your handphone. So, no need for you to use the power supply, light source and cardboard object. The third part of the pre-lab module discussion is the data analysis. Referring to question 11, the focal length of a convex lens f is related to its v and u, also the magnification by the following equation. Equation 1, 1 over f is equal to 1 over u plus 1 over v, and equation 2, m is equal to negative v per u. Rearrange equation 1 and 2 so that you can plot a straight line graph relating the variable m and v. So, when you rearrange the equation by multiplying equation 1 with the v, so you get equation 3. Next, you need to substitute equation 2 into equation 3. You will get that when you rearrange, you get that the m is equal to negative v per f plus 1. Based on the linear graph equation, y is equal to mx plus c, write the suitable quantity being represented by y-axis, x-axis, the gradient of the graph, and y-intercept. So referring to the equation, our y-axis is the magnification m, our x-axis is image distance. Because of that, we will get the gradient which is equal to negative 1 over f, and the intercept is at 1. For question number 13, how to determine the focal length from the graph when the m is equal to negative 1, as in the procedure 10. So from the graph, the image distance v is actually determined by using the extrapolation on the graph where the m is equal to negative 1. And the focal length is calculated using equation 5.2. From the equation 5.2, you will get the relationship between the f, which is equal to v over u. You just need to substitute the value for v from the extrapolation inside this equation, and you will get the next value for f. For question number 14, sketch the expected graph and state the physical quantities that can be obtained from the gradient of the graph. So the expected graph, because of it is a straight line graph, so you will get from the graph m versus v, you will get the straight line graph with the value of gradient is negative 1 over f. And last question, which is question number 15, state 3 precautions taken before and while doing the experiment. So I give you 4 precautions. So the first one is make sure that the lens is clean to get the clearer image. Second is clean the lens with methyl spirit to make sure there is no layer of oil or dirt on the surface of the lens. You need to set up the light source, object, lens, and screen in a straight line because the light travels in the straight line. And the last one is Make sure that there are no other sources of light in the room so that it is easier to get a sharp and clear image. So that's it for our discussion today. Don't forget to subscribe my channel. Thank you and all the best.